Okay, so in the interest of efficiency, I'm going to ask you to help me with something in a second, which is a demo to help get this session up and going. So you will need a smartphone for this, which I think a lot of you have got. Before we get to that, and I'll give you some quick access codes to participate in the demo, just to quickly introduce myself. I'm in developer evangelism at AWS. Most recently, I've started to focus increasingly on data engineering and machine learning topics, but before that, I did quite a bit in serverless and also in AWS Foundation Services. And this talk is sort of on the intersect of serverless and data engineering, and also has some ML bits and pieces in it as well. So it's a pretty interesting tour around a few different areas that I think are getting a lot more relevant to developers that are working in serverless apps as we move beyond applications that are really toys and proof of concepts into applications that have a little bit more, meat, a little bit more horsepower involved in delivering their features. So what are we going to do here? First thing we're going to do is get this demo up and going and get you to participate in helping me collect a little bit of data, which we're going to use for some analytics later on. Then we're going to look at how the demo is architected, what are the service components, how do they interact with each other. And then we're going to dig in a little bit into data ingestion. Bus will talk briefly about Kinesis. I'm going to touch on that again and talk a little bit about how you can integrate Kinesis ingest together with serverless apps that you might run. I think it's one of the most maybe underappreciated AWS services. It solves a lot of problems for customers, particularly customers that are operating at super high scale. If you go into the Nordics and chat with gaming companies like Supercell, some of the other super large users of AWS that are in the ultra high volume mobile gaming space, you'll find that Kinesis is at the heart of a lot of the architectures that they run. It's one of the only services that can solve the kind of data problems that exist in that particular subsegment. Then we'll do some live demos of Glue, which is a data discovery and cataloging service. And then lastly, we'll talk about how you can actually run analytics without operating any instance infrastructure using Athena. So that's what I've got for you. It's essential that you participate. If you don't participate, this will be the worst demo you've ever seen. Okay, so you definitely need to participate in this next part. Okay, and what we have here is we have a chatbot. Now, I built this chatbot to solve a problem that I had, which was coming out into third-party events like this. It's kind of hard to get feedback. I probably won't get data from the organizers of this event, and it's kind of hard for me to tune and optimize the content that I'm delivering. So I figured I could solve this problem by creating a direct channel to interact with people that have seen me speak via popular social media platforms. Then I went to Germany, and I figured out that in Germany, nobody uses Facebook. Okay, so we had to open up a second front, which was a web application as well. So you can interact with this chatbot using one of these two interfaces. Don't type these URLs, by the way. I'm going to show you a QR code in a second that will really, simplify the onboarding experience for this app. Okay. In the background, we've got quite a few different AWS services at play. Of course, we've got Lex, not the topic of this talk, but it's an NLP and NLU engine for writing chatbot applications. Then we've got some Lambda functions behind that that are used for enriching the chatbot experience with things like input validation, doing sentiment analysis on the content, and also allowing us to store the data from the chatbot sessions into the analytical stream. And what we're focusing on in this talk is everything that's on the right-hand side of this slide. Okay, so interact. Here's how you can do this. Either use Facebook Messenger and scan this code inside the ring that you can use inside Facebook Messenger to add a contact, or just directly scan this QR code inside your modern smartphone camera. So directly in iOS and Android, just point the camera at that and it'll pick up that QR code and it'll take you off to that URL. You'll then see a red interface, which is a web app. You don't have to turn on the mic. So you can ignore the ask for mic permissions if you want. Just use text, okay? Just say something like, I want to leave feedback, or I want to provide a rating, okay? Or I want to leave a score, or I want to score a session, or I want to score this talk. And then you'll get into a back and forth dialogue. It'll ask you a few questions about when and where. We're in Milan, okay? So that's important. The date can be today or today's actual date, okay? And ultimately, you'll be asked to provide a score or leave a little bit of feedback. Okay, so I'll just leave that up for a second. And while I do that, just so scan, put your hands up if you need more time. A few people need more time. Okay, so just get one of these applications up and running, and I'll talk while you tap and type away on your smartphone. One of the things you can ask the bot, by the way, is what is your GitHub? And if you ask what my GitHub is, you'll get a link where the source code, the SAM templates, and everything else for the chatbot engine are available in a repo. So all the code is available in the open as well if you want to download it. You can take a look at how things are implemented in the back end. And it answers a few other questions as well. But the main use case is this rating or feedback use case. OK, so while you're interacting with that, obviously stuff is happening in the background. The back and forth that's going on here is a request-response model. Each time you provide an utterance and interact with the chatbot, an event gets fired. Okay, there's a fixed format metadata structure which is sent over to a Lambda function, as you might guess. And then there's a Lambda function which operates on that fixed format JSON document. And we can do things there, as I've already said, like validate whether or not we've got all the data that's required to fulfill this intent. We can validate whether we're trying to rate a session which happens in the future. We can figure out whether we're in a city that I've actually been to. So try to rate me in Cairo, and you'll get back there's no sessions in Cairo, for example. So we've got that validation. But of course, we've also got something that happens when all the data has been provided. When we know when, where, what, and what the score was or what the feedback was, we want to persist that data so that we can create a dashboard and get some useful insights, get some useful analytics from that data collection exercise. And that's where Kinesis comes in. And we create our Kinesis resources using CloudFormation. This is actually embedded inside the same SAM template that spins up the Lambda environment that's required for validation and fulfillment. Okay, so you probably know, maybe you don't, you can mix and match simplified SAM resources together with full-blown CloudFormation resources inside the same template. And that's precisely the approach that I use here. So the top of the template has my Lambda resources in it. And then lower down the template, we've got resource definitions for Kinesis streams, which you can see here. This costs about $11 a month for my data ingest stream. Okay, so I can ingest a high volume of records, certain megabyte per second throughput for that particular price point. It's a fixed cost, but I would still consider it serverless, okay, because it's a low fixed cost, and we can also scale it elastically on demand using CloudWatch metrics about throughput, for example. Okay, so that's my delivery stream. And once we've got that, we can send records into that stream. I sincerely hope that I'm the only presenter today that has Python code samples, because I know, everybody here writes JavaScript except me. And the reason for that is I'm old and I have white hair. And when I was learning to code, JavaScript was a thing that you ran in the browser. You definitely wouldn't run that on a server, right? That would be crazy. Yeah, so still Python. So important tip, must delimit your records with new lines. Okay, fail to delimit your records with new lines, it will break everything. So that's a really important thing to know. Whenever you are sending records to Kinesis, make sure you use a new line delimiter. Okay, and then the other feature that you'll see here is the use of globals with environment variables. So if you look at my source repo and check out the SAM template, we'll see that we're using a 12-factor pattern to inject environment constants into the environment using Lambda environment variables. We can use this for things like using different Kinesis streams for dev and test environments, for example. Okay, so our test data will end up in a different repo. That's how we achieve that. And then we are just posting records into our endpoint using the Kinesis client that we're creating there, which are in this fixed format. Okay, so you'll see the user ID is populated by Lex using a Facebook user ID or a session ID, the location, date, score, and the ID. Those are the attributes that you've probably just provided if you interacted with the system. And that ultimately, in my old architecture, used to end up getting indexed in Elasticsearch. Okay, and you get these records like this over in Elasticsearch, which reflect those objects, one document per line that you submit into your Kinesis stream. Really simple. The problem is this, $111 a month bill for my Elasticsearch cluster. Seems kind of expensive, and I really wanted to try and remove that cost from my architecture. And that's just the cost of running a couple of T2 medium Elasticsearch nodes using the Amazon Elasticsearch service. And of course, 2 nodes is the absolute minimum for durable infrastructure. I want to have them distributed across AZs, right? So that's my sort of minimum cost floor for running my Elasticsearch cluster. And this is the thing that I wanted to tackle really by thinking about how I could change the architecture. Now for that $111, I get Kibana. Great, okay, so this is kind of using a fork to eat a spoon, to eat a soup problem really. I mean, you can use Elasticsearch for visualization and dashboards, but it's really good for search. Okay, it's not quite so good for analytics, probably not as flexible, and probably not as powerful as proper analytics tools. And this is another challenge that I wanted to try and solve. So, how can I do that? Create a data lake. So I want to persist my records in S3 as well as storing them in Elasticsearch. This is actually really simple. I can modify the delivery stream, my Kinesis delivery stream, and I can send a second copy of my records into a target S3 bucket. Okay, and I just end up with a load of documents there containing those same JSON objects that are stored inside my Elasticsearch cluster. Really, really easy to do. And we end up with this kind of architecture where our Kinesis stream is doing dual delivery. So as well as pushing a copy of those documents into ES, we're also storing them in S3, and we end up with this. Interesting things to know. The documents are not fixed in size or consistent in size. And that's because if you look, and you need pretty good eyesight to see this, but buffering hints at the bottom here, we're saying it's either 50 megabytes or 60 seconds intervals on our buffer. So every 60 seconds or 50 megabytes of accumulated data, we're going to flush our buffer and write an object. Okay, so the size of the objects over in S3 is defined by that time period in this case. We don't have enough volume flowing through the stream to give us 50 meg objects. And if we look inside one of those objects, what you'll see is you've got multiple new line delimited records that are created as the data is flushed out of the Kinesis delivery stream buffer and ends up stored inside a series of objects inside S3. So this is our data lake, essentially. It's more like a puddle in this case. Not quite big enough to be a data lake, but we're accumulating our data over there. Okay, so let's get on to some interactive stuff. Hopefully people have been using that system. And if I jump over onto my S3 console and refresh this, we should see we've got some data from the 10th. Okay, that's this month, and it's the 19th, right? So all the data's in the 19th prefix, so some people have submitted data. And we've got 10 o'clock in the morning, and we've got quite a few records. Some of these files are quite large, so some people have certainly completed the process. So we've got some data there, and we want to discover that schema and start to do some analytics on it using a real-world analytics tool, not a Kibana environment. So this is the Glue console. This is a data discovery and ETL service that we announced last year at AWS reInvent, and it allows us to do automated discovery of data sets that are deposited inside certain repositories, and S3 is one of the supported repositories. So we can create something called a crawler, and we can point that crawler at a particular S3 prefix, which I'm going to grab like this. So we're creating a new auto data discovery crawler here, and we're going to interrogate that particular S3 bucket and prefix. Okay, so that's going to be tightly scoped down onto just the data associated with today's date. Okay, so we're going to discover just a target sub-prefix in the overall data set that's available. I'll show you something else a little bit later, which is a little bit broader in scope. We don't want another data store. We're just going to discover data in that one particular store. And we're going to use a pre-existing IAM role that was created. Okay, and run on demand. And we're going to add a database for that. Finish and run our crawler. Okay, so that'll initiate. This takes about a minute. It's definitely the longest minute of this presentation, because if you're on stage giving a demo and something takes ages, you have to think of something to say while something takes ages, and that's precisely what I'm doing right now. Is trying to kind of talk over the time that it takes to spin this up. And it's kind of weird with the cloud, isn't it, that we now consider waiting a minute to have our data discovery process execute a kind of awkward and inconvenient truth. How long would it have taken to do this before we had platforms like AWS? Kind of an amusing thing to think about while we wait the roughly 1 minute it takes for this process to work. So that's going to happen in the background. And what's happening there in practice is the crawler is loading all of the objects that are available within the prefix that I've specified. Okay, and it's using a pattern matching algo to figure out what the schema of the JSON is. Okay, so it'll work out what kind of fields we've got, what kind of data types are in those fields. It will also do things like unpack nested JSON objects and convert those into structs. So we can have pretty sophisticated multi-level nested JSON sitting inside our ingest objects, and we'll end up with a schema that reflects that in just a minute or so after that data has been discovered. Obviously, with larger data sets, your mileage may vary and it may take longer, okay? But it is basically a hands-off process. And in a second, this will finish. Actually, if we jump over onto databases, and we can refresh this, you'll see we've got our new database that's being created there. So this is containing tables based on the schema of those JSON objects. And if we jump into this table, you'll see that it matches the prefix that was used. And there's a couple of things I need to do here. First is I need to delete this partition key because we want to treat all of our data as one contiguous set of data. So I'll delete that out of there and save that. And then you'll see in the schema that the schema reflects the attributes within the JSON objects that were ingested. So we've got a successful discovery run that's taken place here. We've got our date, our ID, our comprehend sentiment structure, which is a nested JSON object that's been unpacked with a couple more attributes in it. Okay, so it's worked in discovering some of the complexity within the data set that we have there. And we've now got an endpoint available for us within the Glue data catalog. And we can use that endpoint together with Athena. Okay, so if I jump out over onto QuickSight, which is our visualization tool, I can create a new data set via Athena. This will automatically discover data sources that are available within the Glue data catalog, and it will also work using their associated schema. That's the table that we created earlier. We can load this data into our in-memory query engine, which is called Spice. So we'll bring that into an in-memory cluster for analytics, and then we can do something really simple like drop the score in here and discover that 27 people submitted a score, and the average score that they gave was 4.59. So it's really that simple. We didn't have to do anything in terms of manually defining our schema. And of course, there's no infrastructure running here. What we have within Athena is a set of warm nodes available for customers to use. When you execute a query on Athena, those nodes get spun up as Presto workers. They use the schema definition that's defined within the Glue data catalog, and then they can work to analyze the data that's available inside S3 and present that data to you via a JDBC standard interface. So you can make SQL queries against that endpoint and receive results directly back into your query tool or into QuickSight if you're using that. And your cost is simply the cost for the amount of data that's been scanned. So there is no cluster, there is no Redshift cluster, there are no instances, there is no EMR. There's just an on-demand pool of capacity that you can use to run analytics queries against that data and receive those results right back to you. Okay. I did say that I would show you a slightly larger data set. So I've been running this demo quite a bit this year. Try to use this one. Here we go. Yeah. So this is a more comprehensive dashboard which replicates the features that you probably saw in that Kibana dashboard up front, where you've got things like sentiment analysis, session score, overall averages. You can see all of the data from Milan's here. It's been done in quite a few locations, this talk, around the world. And here are the raw data from our sentiment analysis queries as well. Okay, great. And what we ended up with there is an overall architecture that now looks like this. Okay, so I didn't actually retire the Elasticsearch cluster. If I wanted to do that, it's just a matter of making a couple of changes inside those SAM templates, and that will delete those resources. I think Elasticsearch still has a role in this kind of architecture because for debugging, for example, it's super quick and easy to use ad hoc queries within Elasticsearch to find particular users or to see the long-form records as they are in their ingested form directly within Kinesis. And that does offer some benefit, but it's not really the right tool for this kind of analytical workload. And that's why I implemented this second branch here, which gives us a different and more effective way to take a look at the data that we're generating. Okay, so I hope that's given you a flavor of how easy it is to get started with that kind of approach. Does anybody have any questions they want to ask about anything they've seen there?
Could you elaborate a bit on that, why Kibana is not the right tool for doing analytics?
Because most analysts aren't trained or familiar with it as a tool chain. Okay, so your analysts are working with a suite of tools that use JDBC as a connectivity layer. Okay, in fact, the predominant one is still Excel. Okay, but you're unfortunately, but you're still going to have users of tools like Tableau and others that are very familiar with that kind of tooling environment. And that is really important in providing the right kind of users with the right kinds of capabilities. We can all write filters in Kibana and use the query language that we've learned to enable us to do that. Most real users of analytical tools have no idea how to get started with that. So I would say the main challenge is providing support for the right kind of tooling, the tooling that the experts in data analysis tend to use. Yeah.
1 and 2. So you mentioned that you can still use Elasticsearch, it still has a place in this stack because for debugging you can search the raw inputs.
Yep.
But could you not do the same thing with Athena already because the table is already there?
Yeah, you can do that. And you can create a table object within QuickSight actually, which just dumps out all of the attributes. So it's certainly possible to do that. As I just said to your adjacent questioner, the fact that we know the query language actually makes it really simple and easy for us to run that kind of system for ad hoc queries without the overhead of necessarily spinning up a full-blown analytics tool of the type that I was just talking about a second ago. It doesn't, of course, mean necessarily you need both tools in all environments. If you were going to run this in, say, development, maybe you have your small Elasticsearch cluster there, but in production where your real use case target is getting those analytical insights into the hands of the right users, maybe ES is not present in that environment, and that's where you just have your full-blown analytics stack. Okay, so I would say use the right tool in the right environment. And you can use, obviously, conditionals in the CloudFormation template generators that you use to build those different environments for those different use cases as well. That's probably how I would tackle it if I was going to put the right tool in the right environment.
If you could please go back to the architectural diagram.
This one?
Yeah.
Yeah.
Thank you. So you're pushing data to Elasticsearch and S3 at the same time.
I am now, yeah.
So how do you manage the consistency of data here? Do you have any automation or?
You don't need to. With Kinesis, you've got reliable deliver once capabilities. So Kinesis will make sure that the same object, the same record is delivered consistently to both targets.
What if one of the one fails? So does it have the persistence?
It's a good question. So S3 is not going to fail. You know, you're going to be reliably delivering your records into S3, and that could be delivered considered a fallback target, where and that's actually why the semantics within the CloudFormation definitions for those resources have S3 available as a backup target, because we would actually recommend that if you're using another target like Redshift or Elasticsearch, which are the two of the targets that are available, you have S3 configured as a backup, as a fallback, because it has such high durability and availability characteristics. The simple answer to your question is if your Elasticsearch cluster is offline, or you're resizing your Redshift cluster, for example, those records cannot be ingested into that target because there's nowhere for them to be written to. So the common use case for S3 is as a fallback target for other targets that you might have set up. And then you could use a mechanism for bulk loading data from S3 into an analytics cluster like Redshift, for example, after the fact. Yeah.
And just one more thing. How about a queue process instead of Kinesis?
So we announced quite recently support for Lambda within SQS. Okay, so you can now trigger Lambda in response to messages in an SQS queue. It's intended for a different kind of use case, really. So that's for batch-based processing. And with Kinesis, you are provisioning guaranteed levels of throughput, and you will also see more rapid delivery characteristics with Kinesis as well. So typically your records, your events will flow through the stream much, much more quickly than the state in an SQS environment will converge. So for real-time applications where you want to process events with real high velocity, then Kinesis is going to be a much better fit for those use cases than SQS is. SQS is a sort of classic async processing tool, really. So it's intended for a slightly different use case.
And I can add one thing if you want.
Yep.
It's also about having multiple consumers to do different things with the same data. While in a queue, you take the message and that's consumed.
Yeah, it's consumed. That's actually correct. One of the reasons that I set up this architecture in the first place is I was originally using a third-party sentiment analysis engine, okay, and the performance on the third-party sentiment analysis engine was highly variable. So I used to have my sentiment analysis as an async enrichment task running off the Kinesis stream. So I would not analyze the sentiment of the comments that were made in feedback at the point at which the chatbot fulfilled. Okay, I would take those records, I would have the free text comment in the stream, and then I would have a Lambda function which asynchronously processed the records and enriched them with the sentiment data. That was the old architecture. And then when we introduced our comprehend service, the performance was much, much higher, like typically under 200 milliseconds for a request response, and I could change the architecture around a bit and remove that async processing step. This is a mechanism for, well, I'm sure a lot of you that have built applications using this approach have used this, trying to make your functionality as discrete as possible, okay? So the things that are blocking or have user interaction with them have the minimum possible execution time, and then take out activities that are either invisible to the user or need to be non-blocking activities and put them out into an async process. And that's something that you can do with Lambda, actually. You can have additional workers that do enrichment, and I think this was something that Bussell talked about before as well, using Lambda workers on Kinesis streams to enrich data as it flows through the stream. So you could do that and then persist the data in a target as well. That's what the architecture first looked like.
We can do one more question. Anyone that didn't ask a question? Okay, sorry.
Oh, somebody in the light that I can actually see talking. That's great. It's just
Hi.
darkness at the front here.
Which kind of data can you infer from with Glue? Like document, time series, graph-like data structures?
Not graph-like data structures, but attribute-based data structures. Okay, so it will do data types, so integers, dates, strings, and it will also do structs, which are embedded JSON within fields, which are themselves the strings, and it will pull out the same data types from those structs as well. You can, as you've seen, you can post-edit the schema that you get to fix any issues that might occur as well. Okay, so you can post-edit in here and make changes if necessary. One thing that I didn't show is over in this Spice tool in QuickSight, you have additional data management capabilities in here as well. So you can edit a data set in here, and you can do field calculations here and other things as well, which are downstream of data discovery in Glue. So there's a relatively powerful second layer there for things like advanced JSON manipulation, or using intrinsic functions for things like string decomposition to determine fields from non-JSON data types that might be embedded within strings. So there's quite a bit of power in the different tools in combination here.
And if you want to have some kind of migration engine, you can use QuickSight to achieve that.
Define what you mean by a migration engine.
For example, in Python, you have Alembic and SQL Alchemy. You can use SQL Alchemy in combination with Alembic, and you have the
you have
there's an
additional ETL capability inside Glue, which we didn't talk about here today, which is PySpark ETL code that you can write and run on a schedule within Glue. So you can do very sophisticated data transformations using the tools you've just described directly within the ETL tool if you want. Quite a few different options.
Thank you very much, Ian.
Okay, thank you.